In this video, I'm going to discuss problems 1 through 8 from the Chapter 2 exam review. So problems 1 through 8 talk about finding slope. The first 4 will be finding slope from a graph, and the last 4 will be finding slope from 2 points. So here we go. Number 1, we have a graph here, and we're given 2 points. We have the point here, and we have a point here, and we want to know the slope of this line given 2 of its points. So we know that slope is going to be defined as rise over run, or we can say the change in y divided by the change in x. And we're going to make a ratio out of that, so we're going to leave it as a fraction. So what are we doing to go from this point to this point? Well, we're coming down 1, 2, 3, 4, and we're going over 1, 2, 3 to the positive side. So since we came down, we're going to call that a negative, and we came down 4, so 1, 2, 3, 4, so negative 4. And then from where we left off, we went over 1, 2, 3, and since we went to the right, that's in the positive direction. So we can make a fraction out of this, and it's going to be the change in our y, which was negative 4, over the change in our x, which was a positive 3. So then, since we have a negative and a positive, we really can just say the slope is negative 4/3. So on number 1, m equals negative 4/3. On number 2, it seems that we have a horizontal line, and if you don't already off the top of your head know what the slope of a horizontal line is, we can figure it out. So to go from this point to this point, we're going to say, well, how far did we go up and how far did we go over? So rise over run, so how far did we go up? Well, it looks like we're not going up or down any, so that's going to be 0, but we did go over 1, 2, 3, 4, 5, so positive 5. So 0 divided by any number other than 0 is just going to be 0. So the slope of this horizontal line is 0. So number 2 is m equals 0. For number 3, it seems that we have a vertical line, so if you don't already know what the slope of a vertical line is, we can figure it out. So the slope has to do with rise over run. So to go from this point down to this point, how far did we go up or down? Well, we came down 1, so we're going to say minus 1. And then how far right or left did we move? Well, we didn't move it at all right or left, so 0 units. So the slope is going to be negative 1 over 0, but anything with a 0 on the bottom, division by 0 will always be undefined because you can't divide by 0. So we're going to say m equals undefined. And we know that the slope of all vertical lines will be undefined. So number 3, m equals undefined. In number 4, we have another line here. We're going to go from this point up to this point. We're trying to decide how far up or over or what do we do. So m equals, so m represents slope. So how far up or down did we go first? Because rise over run. We went up 1, 2, 3, 4, 5, 6. So if I were to draw this line here, I went up 6. And then from where we left off, how far did we go over? Well, 1, 2, 3. So we went 3, and since it's to the right, that's in the positive direction. So we went up positive 6 there, and went right, which is a positive 3. So a rise over run will be positive 6 over positive 3. And we can reduce this because 6 divided by 3 is just 2, and it's positive 2. So we're going to say, for number 4, m equals 2. In numbers 5 through 8, instead of being given a graph, we're just given 2 ordered pairs. So number 5, the ordered pairs are negative 10 and 15, and then negative 7 and 3. So our formula to find slope, m equals y2 minus y1 over x2 minus x1. So we're going to call this first point, point 1, and the second point, point 2. So here's my x-coordinate, so he'll be x1. Here's my y-coordinate, so he'll be y1. On my second point, here's my x-coordinate, so he's x2. And here's my y-coordinate, so he's y2. So really all I'm going to do now is just plug each one of these values into my formula. So y2 is 3 minus y1, which is 15, and that's going to be over x2, which is negative 7, and I'm going to minus x1, which is a negative 10. Now you have to be really careful, especially when your second value is a negative, like this negative 10, because we're really subtracting a negative, which when you go through and do these operations will really be adding. But let's not get too far ahead of ourselves. So 3 minus 15 will be negative 12 over negative 7 plus 10, which should be 3. And negative 12 divided by 3 is just negative 4. So on number 5, it looks like my slope is negative 4. M equals negative 4. On number 6, I went ahead and wrote the slope formula over here again for us. So this should be x1, y1, and then x2, y2, given our points, because the first coordinate is always the x-coordinate, the second coordinate is always the y-coordinate. We'll call this one our first point, and this one our second point. So when I put this in my formula, m equals y2 is 16, minus y1, which is 16, x2, which is 14, minus x1, which is 5. So 16 minus 16 is 0, over 14 minus 5 is 9. And 0 divided by any number other than 0 is just 0. So we're going to say here m equals 0. And if we recall from problem number 2, where we actually had a graph and we said the slope was 0, remember that it was a horizontal line. So if you were to graph 5, 16 and 14, 16, you would notice it's going to be another horizontal line. So in this case, number 6, m equals 0. Now in number 7, we're given a couple more ordered pairs. We have this negative 10, negative 1, and then negative 6, negative 19. Once again, we're going to put it in our slope formula, where y2 minus y1, so it'll be y2, so negative 19, minus y1, which is a negative 1. And again, be careful, because the formula says we're minusing, and this guy happens to be negative, so we're actually minusing a negative. Then we have x2, so negative 6, minus x1, which is a negative 10. So we have tons of these negative signs running around here. So both the top and bottom, when you subtract a negative, it's going to go swoosh, swoosh, and it makes it positive or plus. So negative 19 plus 1 will be negative 18, and negative 6 plus 10 will be 4. So negative 18 over 4. I wonder, can we reduce that? Well, it looks like both of them are even, so I could take at least a 2 out of the top and the bottom. It looks like I would get negative 9 halves. And that's all the further that we can reduce that. So we're going to say m equals negative 9 halves. Number 8 is the last one in this section. So we're given, again, two ordered pairs, 18:6 and 18:16, and we're going to use our formula here. So m equals y2 minus y1, so 16 minus 6, over x2 minus x1, so 18 minus 18. Now on the top, 16 minus 6 will be 10. On the bottom, 18 minus 18 is 0. Uh-oh, interesting. So we have a 0 on the bottom now. Remember what we said last time. We can't divide by 0, so we're going to have to say undefined. And if you were to look at these points a little more closely, 18:6 and 18:16, these 2 points are just going to be right on top of each other, vertically speaking. So like 18:6 and then 18:16. So they would create a vertical line. And if you recall from number 3 a little bit ago that we did, all vertical lines have a slope that's undefined. So for number 8, m equals undefined.